Today we're going to be looking at reviewing algebra. So the learning goals for this session, we're going to be simplifying the expressions using the four operations, which are, if you remember, addition, subtraction, multiplication and division. We're going to look at expanding expressions using the distributive law. So that's an expression involving brackets. We'll expand those brackets away. And we've got factorising expressions as well, which is the inverse of the expanding expression. So that's putting brackets back in. And we'll also look at evaluating expressions using substituted values. So in simplifying expressions, if you recall, expressions that involve addition and subtraction can be simplified by collecting like terms. And remember, like terms have the same combination of variables. So the same combo of variables. So that means that, for example, with our first example here, 3x minus 7x plus x, the combination of variables is just the x there. They all contain an x. And so that means that we can have the 3x's subtracting away 7x's for minus 4x's, add another x on, and that's the same as negative 3x or subtracting 3x. For our second example here, we've got the variable being a squared b and b a squared. Remember, they're the same. A squared b is going to be equal to b a squared. It doesn't matter which order you do them in, because if we have any number times another number by the commutative law, they can be multiplied in any order. It doesn't matter which order they're multiplied in. So if I've got 6 of the a squared b's minus one of them, then I'm left with 5. So that's why we get the answer there, collecting like terms. When we're looking at multiplication and division, we can look at simplifying those as well, remembering that because of that commutative law, we can switch them around, multiply them in different order and simplify them that way. So for example, our first example here, 2h times 7ht, we can multiply the 2 and the 7 together to get 14. The h times h is h squared, so we've got the h squared there, and we've got the multiplied by t there as well. So we've got 14 h squared t as a simplification there. We can do the same thing with division. So for our example that we've got here, negative 6 a squared b divided by ab, we can express that as a division using a vinculum here to make it easier to kind of have a look at. And we can look at being able to make some cancellations. And remember, that term cancellation is essentially because if I have b and divide by b, then that is going to be equal to 1. So that's why we can cancel the b's, because b divided by b, or anything divided by itself, is going to be equal to 1, and multiplying by 1 doesn't change the value. So for our example here, we can cancel those b's. We can also cancel one of the a's. So that's a squared, which is a times a, and we can remove one of those a's by cancelling it with the a below. So we've got we'll be left with negative 6a, which is what we're left with in the answer here. Okay, so let's have a look at some examples now with these questions. So if we look at our first example, example A, we've got 3a squared b minus 2a squared b. That minus sign's a bit not great, but oh well, we'll get over it. So that we can simply just say, well, I've got 3 of them, I take away 2, I'm left with 1, so I'm just left with a squared b. So remember that you could write 1a squared b, but that 1 multiplied by a squared b is redundant. It doesn't need to be there. So we can just have a look at answering and giving our answer as a squared b there. So for our second example, we've got, if we write it down, 5xy plus 2xy squared minus 2xy plus 3y squared x. So if we're looking here at our like terms. The like terms we've got xy here and minus 2xy, and we've got plus 2xy squared and plus 3y squared x. Those are like terms because they, even though they're in the different order, they're still going to be equivalent. So xy squared is the same as y squared x. So I have got 5 of the xy's and I take away 2 xy's, so I'm left with 3 xy's. And I've got 2 xy squareds and add 3, so that means I'm going to be left with 5 xy squareds. When we're answering our question, it's always going to be helpful to, or it's convention to put them in alphabetical order. So xy squared rather than y squared x, even though that's the way that one of them is written in the actual question. So let's have a look now at C. Answer C here, or example C. We've got negative 3p squared r times 2pr. And if we have a look at collecting or rearranging those, I've got the negative 3 times the 2, which will be negative 6. I've got p squared and then another multiplied by p, so that means I'm going to have 3 p's in total, so p times p, which is p cubed, and then I've got r times r, which is going to be r squared. So that's what we're left with, negative 6p cubed, r squared for our answer to question C there. For D, what we can look at, we've got negative 7xy divided by 14y, and we can look at cancelling, which means we're essentially dividing same numbers by themselves to make it simpler. So I've got y divided by y, so I can cancel those, and I can also have a look at dividing the above the vinculum here by the same number as I divide the bottom by, essentially cancelling. So I can divide the top by 7 and I get 1, and divide the 14 by 7 and I get 2. So what we've actually simplified our expression here to is negative 1x, but we can just write x, divided by 2, so negative x over 2. Looking at expanding and factorising now, remember that the distributive law is used to expand brackets. That means if I've got a times b, that's a multiplied by the b, a multiplied by b, and then plus a multiplied by c. So we separate it out, remove the brackets, and we have a multiplied by b plus a times c. So we can do that with our examples here as well. 2 times x is going to be the 2x, and 2 times 7, that's going to be 14. We can also look at a more complex example, and we need to, well, not necessarily complex, but need to be very, very careful when looking at negative values. If I've got negative x, then that negative x needs to be multiplied by the 3, and the negative x needs to be multiplied by negative x, because that's the same as adding negative x. Subtracting away x is the same as adding negative x. So we need to be careful to make sure that we incorporate that negative into our calculation as well. So our negative x times 3, that's easy, that's negative 3x. But if we need to just be very careful with the negative x times the minus x in here, that's negative x times negative x. Negative times a negative is a positive, so that's why we've got a plus here. And then x times x is x squared. Okay, so we just need to be very careful when practicing those kinds of problems. Expressions can be factorised by taking out the common factor. So once again, we've got the opposite to our expanding the brackets. What we're looking at doing this time is we're looking at placing those brackets back in. So for our first example here, looking at for the highest common factor, the highest common factor of 3x and 12 is going to be 3. So we divide the 3x by the 3, the highest common factor, to get what's going to go inside the brackets. So if our HCF here, HCF is 3, then that goes outside the brackets. HCF is 3 goes outside the brackets there. And then we divide each of the terms. So 3x and 12 by 3 to get what goes inside the bracket. So 3x divided by 3 is x, and minus 12 divided by 3 is minus 4. So we're left with what's in the brackets there, and that is now a factorised statement. When we're looking at a more complex statement where we've got 3 terms, we need to look at the highest common factor of all the terms. So if we have a look at the numbers that we have out the front of all our terms, 9, 6 and 3, the highest common factor out of all of those numbers is 3 again, okay, is 3. And if we have a look at the combinations of variables, we've got x squared y, x, y and x. The only one that is common to all 3 is x. So the highest common factor then of each of our 3 terms is 3x. Oops, 3x. Horribly messy, but there you go. So what we need to do then is take the highest common factor and put it outside the brackets like we have done here, and then divide each term by 3x. So we have 9x squared y divided by 3x, and the 9 divided by 3 we're left with 3. X squared y divided by x, we're just left with xy. Minus 6xy, the 6 divided by 3 is 2, and the xy divided by x, we're just left with the y. The x's have cancelled, and then if I've got 3x divided by 3x, that's just going to be left with 1. So that's going to be our terms that are then inside the brackets. So let's have a look at a couple of examples now. If we look at example 1a, here we've got to expand this expression, negative 3x x minus y. So expanding this out, we've got negative 3x times x is going to be negative 3x squared. Then I've got a negative times a negative, so it'll be a positive, and it's negative 3 at x, it'll be positive, so it'll be 3x times y, it'll just be 3xy. For b, we've got here, we're not asked to collect like terms here, but I think we're going to definitely need to do that. We've got 3x plus 2 plus 4, 2x minus 4. That's going to be a minus there. So expanding this out, the 3 times x is 3x, 3 times 2 is 6, plus 4 times 2x is 8x, plus 4 times minus 4 is going to be minus 16. Now we definitely need to make sure we collect like terms here. So if I've got 3 x's and I add 8 x's, I will have 11 x's. And then if I've got 6 and I take away 16, that's going to be the same as subtracting 10. We've got 2a here. We're going to look at factorising now. 3x minus 9. So taking out the highest common factor of 3x and 9, the highest common factor is 3. So that means inside the brackets I'm going to do 3x divided by 3, which is just x, and then minus 9 divided by 3, which is going to be minus 3. What we can do is we can check for our when we're factorising whether we've factorised correctly by expanding the brackets back out again, even just in our head to give it a quick check. So 3 times x is 3x, 3 times minus 3 is the minus 9 there. We can have a look then at part B. We've got 2x squared plus 4x, 2x squared plus 4x. And our highest common numeral factor between our two terms is going to be 2, but there's also the x that is common to both of them as well. So one of the x's will be common to both of them. So our highest common factor is 2x. When we have a look at what goes inside our brackets, we need to do 2x squared divided by 2x. We'll just be left with an x left over, and then 4x divided by 2x is going to be just 2. So we can check our answer again, expand it out. 2x times x is 2x squared, which is what we started with, and then 2x times 2 is 4x, which is what we started with there as well. Last section that we have here, For evaluating expressions, we can evaluate expressions by substituting a value in for each variable if we're told what those variables are. We need to make sure we always follow the order of operations, and we need to be very careful with negative values that we don't make a mistake. A common mistake that is made is when someone might say, oh, I've got, if x equals negative 2, and then I have x squared, then x squared, that equals negative 2 squared, so then that's the same as negative 4. That is wrong. Okay, so that's because what the person hasn't done, what they should have done, is they should have said, okay, I've got x squared, that's equal to negative 2 squared, that's negative 2 times negative 2, and a negative times a negative is a positive. So negative 2 times negative 2 is positive 4. So it's not negative 4, it's positive 4 there. So in the example that we have here, the example that we've given, we've substituted in here that 3x squared, our value for x is negative 2, and our value for y is positive 4. We've got the values here and just substituted them straight in. So negative, you'll notice the negative has been put in brackets here, and then we've subtracted away y, which is 4. So we've just plugged those numbers straight into where those variables are in our expression. So then we've made one step to solving it. We've looked at expanding those brackets first. Remembering the order of operations, we start out, if we remember the order of operations at the very top, we start out with brackets, and then we look at indices, so we look at exponents, or powers, whatever you want to call them, powers, exponents, indices, and then we look at multiplication and division, and then we look at addition and subtraction. Okay, so that's our order of operations. So making sure we start with those brackets, we then have a look at getting the answer there. Negative 2 squared is going to be positive 4, as we've done here down the bottom. We've got 3 times 4 minus 2, that's going to be 8, because the 3 times 4 is 12. Take away the 4 and we get 8, and then 8 divided by 2 is 4. Now remember that if I've got an expression like this one here, that if I've got the vinculum there, everything above the vinculum, it's as if they're in brackets, and everything below the vinculum, it's as if they're in brackets. So they need to be done first before doing the division that's included there. That's why we've done this first the top line here before we did the divide, dividing the 8 divided by 2. So let's have a look at an example. We've got the expression a squared minus 2bc, and that's going to be equal to negative 3 squared, if we have a look at what we're substituting in, minus 2 times 5 times negative 1. So complete the order of operations. We've got negative 3 times negative 3 is going to be positive 9. And we've got minus 2 times 5 times negative 1. So it's going to be minus times minus. So it's going to be plus 2 times 5 times 1 is 10. So our answer here is 19 as far as the answer to that substitution goes. Of course, there's nothing to stop you just entering in the expression exactly as this into your calculator, and you should get the exact same answer.